In this tutorial, we're still going to be finding asymptotes and intercepts for rational functions. The only difference here is we're going to be looking at oblique asymptotes rather than horizontal and vertical ones. So in this example, what you need to notice is that the degree of the top, the numerator, is 1 more than the degree of the bottom. So the degree of the top is 2, the degree of the bottom is 1. When that happens, when there's a difference between them of 1, we know that when the top is bigger, there are no horizontal asymptotes, but we do know that there is going to be what's called an oblique asymptote, or one that's tilted. So when I do this, what I have to first do is divide these two expressions. So I'm going to do -3 since we have x plus 3. I need to put -3 in the box. And then my coefficients are 1, 1, -8. I'm going to divide this out. I get 1. -3 times 1 is -3. I get -2. And then finally I get +6, which gives me a remainder of -2. But when we're trying to find the asymptote, the remainder doesn't matter. What matters is the function we get in the end here, which is going to be x minus 2. What you're going to see is you're going to have the line x minus 2 become one of the asymptotes of the function. And if we pull up the graph real quick to look at it, as you can see there, we do have that line y equals x minus 2 as acting as an asymptote. So the other thing we need to look for is intercepts, and that is no different than what we've been doing before. When we want to find the y-intercept, what we're going to do is figure out what f of 0 is. So 0 squared plus 0 minus 8 over 0 plus 3 gives me -8/3. So I have a y-intercept of y equals -8/3. And my x-intercept, what we're going to do is figure out the zeros, which would basically be the factors of the top. So x squared plus x minus 8 is the same as x. Well, actually, I tried to make that a little easier than it was. We're actually going to have to use the quadratic formula here to figure that out, or another method, but we can't use our simple AC method here. So x equals the opposite of b, so -1, plus or minus the square root of b squared, which is 1, minus 4 times 1 times -8. So 4 times 1 times -8 is -32, so we end up having plus 32 over 2a, which would be 2 times 1, or 2. So x equals -1 plus or minus the square root of 33 over 2, and those will be my two x-intercepts. So we can say -1 plus or minus square root of 33 over 2, and we have one y-intercept as shown in the graph. It crosses at about -8/3, and then here are my two x-intercepts that we discovered using the quadratic formula. So here is an example problem that does involve an oblique asymptote. So go ahead and see if you can figure that one out.